Let's begin. Today is December 5th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 4, 7, 10, 12, 18, and 22. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our middle digit, the square digit, and the Turing Machine will be comparing it to the number 4. So should the value of square be less than 4? Should it be equal to 4, or should the value of square be greater than 4? Criteria card B will take a look at our last digit, the circle digit, and the Turing Machine will let us know whether its value is an even digit or an odd digit. Criteria card C will take a look at our 3-digit solution, and the Turing Machine will let us know how many of those digits are 4. Are there no 4s? Is a single 4? Or perhaps 2? Maybe even all 3 are 4. Criteria card D will take a look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card E will take a look at our 3 digits, triangle, square, and circle, add them together, and the Turing Machine will let us know whether the sum total is an even quantity or an odd quantity. And finally, criteria card F will take a look at our 3 digits, from triangle to square to circle, and will let us know a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they are increasing, as in the example 135, or should the 3 digits appear in a descending order, or basically decreasing, as in the example 421, or should the 3-digit solution exhibit no order? So let's take a look at the example of 231. Notice it goes from 2 to 3, it increases, and then goes from 3 to 1, decreasing. Of course, you could also have a code that's decreasing and then increasing, but basically it's that shift from one to the other that is one way to define a 3-digit code as having no order. We've also seen in other puzzles where if you have consecutive equal digits, that can exhibit no order as well. So for example, if you had the code 225, when it goes from 2 to 2, there is no change. It neither increases nor decreases. So that's what I mean by consecutive equal digits exhibiting no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card B. Okay, so the Turing Machine does not approve my choice in circle. I did pick an even 4, but since the Turing Machine does not agree with that, it's informing us that circle actually should be odd. So let's go ahead and type that up in our notes in section B. And we'll say that circle is an odd digit. And of course, since circle is odd, let's go ahead and cross out the 2 evens. So 2 and 4. I think the next thing I'd like to test is criteria card E. Okay, so again, the Turing Machine does not approve. Notice that criteria card E, we are adding up the 3 digits. So let's go ahead and do that with the proposal. So 3 plus 1 is 4, 4 plus 4 is 8. 8 is an even quantity, but again, since the Turing Machine does not agree with that, it's letting us know that the sum total should actually be odd. So let's go ahead and type that up in our notes in section E. And again, that is that triangle plus square plus circle should be an odd quantity. And so what can we take away from that? Well, we've already established that circle itself is odd. So in order for the sum total to remain odd, that means that triangle and square have to be of the same type. What I mean by that is they both have to be either both even or both odd. Because in that same situation, when you add up two evens and two odds, that sum thus far would be even. And then of course, when you add circle, the odd circle value, that would then result in a sum total that is odd. So we're looking for a solution that's either even, odd, or all odd. So something to look into using our criteria cards. So let's see, what else can we test? Well, it is interesting if criteria card C would play out if we have a, let's see, what would happen? Obviously, we can't have 3 4s, but if you have at least 1 4, then that would also indicate that the other digit, perhaps triangle or square, one or the other, would be either a 4 or 2, meaning that they both have to be even. So even the presence of a single 4 would inform us, actually it would inform us that there's a 4 and a 2. Very interesting. Now what about if there is no 4? Well, if there is no 4, then if there are evens, they'd both have to be 2s. So that's a very interesting scenario. Let's see, what else? Well, I do have a square 1, so if it fails, then we know it's either equal to 4 or greater than 4. But if it is a success, at least we know we're in that range. So I think I'm going to go ahead and test criteria card A. Okay, so it does not approve of my choice for square. Again, my square value of 1 is less than 4, but that's not true. So either square is equal to 4 or greater than 4. So let's go ahead and type that up in our notes for section A, and we'll say that square is either equal to or is greater than 4. And so that will allow us to cross out 1, 2, and 3. And of course that means that, again, square is either 4 or 5. And let's see, anything else? No, I think that is it. Okay, well, we did complete our 3 Turing tests for this round. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So even though we tested criteria card A, again, it's still outstanding. Is it a 4 or a 5 in square? We didn't query the quantity of 4s. So there still could be 2 of them, that's possible, or 1 of them. And then we also did not test criteria card D, comparing our first and last digits, and the ordering criteria card F. So let me see. I seem to recall that if you have criteria card D and F, that there's a way we can deduce that there should be no order. So let's see. If we suppose that the solution is ascending, meaning that the digits are increasing from triangle to square to circle. So if it's ascending, we would know for a fact that triangle should be less than circle. and therefore this card would be irrelevant. And a similar argument can be said if the 3-digit code is descending, meaning that triangle is larger and from square to circle it gets smaller. So in that scenario, we would know that triangle should be greater than circle, again making this criteria card irrelevant. So for that fact, I think it's safe to deduce that our solution should have no order. So we'll say that we'll deduce that the solution has no order. And remember that, as I described at the top of the video, not only do we have no order to be represented as, a shift from increasing to decreasing or vice versa, but also if you have consecutive equal digits. So that's also an option. So let's see, since we didn't see the number of 4s, if it were, there could be a single 4, and therefore, and that would mean that we'd have to have 2 evens if we have a single 4. It could be something like 2, 4, and then obviously criteria card D would help us compare our first and last digits. So it could be something like 2, 4, 3 or 2, 4, 1. That's a possibility. It could also be that you could have 4, 4. Well, I don't think you could have 4, 4 because both of the, well, no, that's not true. I guess it could be 4, 4, 5. I was going to say that you cannot distinguish between 4, 4, 1 and 4, 4, 3 since they're both smaller. Circle is, the 1 and 3 are smaller than 4. You can't distinguish, but it could be 4, 4, 5. So let's go ahead. Let's see if it was, let's go ahead and do 2, 4, and let's say 2, 4, 3. That sounds promising. So let's see. Just to check, is our middle digit equal to 4 or greater than 4? Yeah, I did pick a 4. Circle has to be odd. Yeah, it's a 3. And the sum total is odd. Yes. Okay, so let's go ahead with that. And let's test criteria card C. Okay, so it does approve of a single 4. So that's awesome. So let's type it up as that the solution has a single 4-digit. Okay. And that means, and I'll add it to the next line, that there is, let's see, there is also a 2. Remember, as I mentioned, that you have to have either 2 evens or 2 odds in triangle and square. The fact that a single 4 is present really informs us that there has to be a 2. So for that fact, the only 2 available is in triangle. So that means that we can cross out everything but the 2 in triangle. And that would mean that we'd be able to deduce that square should actually be the 4. So let me type that up, deduce that it actually equals 4. So let's go ahead and cross out the greater than. Let's cross out the 5. And so we have 2, 4. So that would mean that because of the no order, that means circle cannot be a 5. And so, yeah, now either we're going to pick the 1 or the 3, right? Because each one, 1 is less than 2, but 3 is greater than 2. So now we get to test criteria card D. And it does approve, so I did pick a 2, 3, so triangle is less than circle. So let's go ahead and type that up, and we'll say that triangle is less than circle. So triangle is less than circle. And because of the 2 checks, and yeah, it's 2, 4, 3. So let's go ahead and cross out the 1 so that triangle is smaller than circle. So yeah, it looks like our solution is 2, 4, 3. And so let's quickly review that. So we did deduce based on really criteria card C that square is our 4. Okay, then we do have that. That last digit is odd. It is. And we have a single 4, but that would also mean that we would have to have another even, the 2. Since the sum total has to be odd, and that's what it is, 6 and 3 is 9, that is odd. And our first is smaller than our last. Yeah, 2 is less than 3, and it has no order. It increases, then decreases. Well, that looks like a very promising solution. So let's go verify. 2, 4, 3 as our solution. 2, 4, 3, and let's see. Well, fantastic, yes. And how do we do versus a Turing machine? Well, the puzzle is a 6 criteria card puzzle, and we only had to do 5 tests. So that's very promising. So in the first round, we did A, B, E, all incorrect. And then we did C, D in the second round, and we outright deduced F. So let's go ahead and type that up. So A, B, and E were all incorrect. And then C, D were both correct, and we outright deduced F. Well, fantastic. So we beat the Turing machine by 1 question. So no doubt, having the recollection of a criteria card like D and F, that helped us outright deduce the ordering. So we didn't have to test that. So that was a great advantage that gave us that win. Well, what about you? What criteria cards did you choose? And did you discover anything that you'd like to share? Some aha moment, perhaps. Add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.